dig a bit deeper into digital fabrication. Let's welcome back the two gentlemen we heard from earlier today, Professor Flatt and Dominic Yu. So gentlemen, do come over here and we can applaud for them as they come back. And joining them is Dr. Bernd Liebert. He's Chief Innovation Officer at KUKA. Welcome to you, sir. You can sit in very light. And last but definitely not least, we have Sergey Nefedov. He's Head of Technology Development at Apis Core. So, gentlemen, welcome. You do you'll all have to push the little button on your microphone so that we can actually hear something come out of the microphone. So, to begin, we thought we would just ask kind of a personal question about your own vision of digital fabrication in construction, and specifically, which tool or technology do you see having the greatest potential, or something that you've already seen that excites you in particular? Perhaps we can just ask the new members of our panel who we haven't yet heard from today. So, Dr. Bernd Liebert, do you want to take a stab at that? What would you say for you? What has the greatest potential, or what have you seen that really excites you?
I would like to thank you for inviting me, giving me a chance to talk a little bit about robotics, I hope, and a little bit about our organization and the European approach in robotics. But getting back to your question, I think it's now's the time to open some doors. We are working on human-robot collaboration. We are working on mobile systems. And from the colleague I learned about 3D printing. And I think that's an amazing technology which helps a lot to get a cost reduction and to speed up. Because I think we need much more space to live in Europe, following the requirements, taking a look on the aging society, and individualization. That's another mega trend. I think these are challenges we have to address. And getting into the digitization, which means that we could do some cross-selling, looking to industries like automotive. There is really the chance now to have a lot of fun and to develop really good new things.
Okay, thank you. And Sergey Nefedov, for you, what excites you? What do you see as having the greatest potential in digital fabrication?
First of all, thank you very much for the invitation, and it was a great opportunity to see so many projects what was done here. Personally, for me, I think it's two huge opportunity for this technology. First of all, if we can look little far away, a lot of country worldwide have huge gap between numbers of house already built and what we really need. For example, Indonesia have a gap between 11 or 40 million houses, and it's not something about unique. It's just about roof on the head, and for them, mobile construction robot who can just simple copy paste very simple house, it's already decision this program, but it will be autonomic. It must be full cycle without any human intervention or some small, and of course it must be very cheap material. Not like we develop new material, it will be cost 3 times more, and on this way we cannot take this gap. And another huge opportunity, for example, it's construction out the Earth for construction on Mars. It's another type. Maybe you know, maybe we part of NASA Habitat Challenge on Mars. And we won first phase, and now we prepare for second one. And I think it's a great opportunity. Looks like NASA engineers step by step see this way how we can print full house autonomously without any people in our planet.
All right, so we're quite visionary. So On the one hand, simple homes for people on Earth with mobile autonomous robots on the construction site, and then someday in outer space. So very, very visionary. How about our researchers? Mr. Yud, what about you?
I think we have to differ a bit between maybe also where in the world we see the new things arise. For example, if you look in Japan, where they have a huge labor shortage, they just don't have enough people to build the houses. So what they invest a lot in automating construction, and that's the reason for them. It might be a different reason for when you mentioned that they just need a house. And then maybe in Switzerland it's different again. Maybe we are going for efficiency. We don't have too much space, so we want to maybe have the thing where we have 3 levels on, just where we earlier spent 2 levels on. So I think we have to differ a bit. But for me it's also 3D printing is thinking the most exciting technology. Also because we have already seen the impact that it has in many other industries, not only digital construction. Especially for me as a mechanical engineer, and you quickly want to prototype something, then you send it to the 3D printer and you get it the next day and it's done. So for me, this technology already had a big impact, so I really see that this is also going to have a big impact on the large scale.
And Professor Flatt?
So I guess mine are different levels. I was trying to think how I would start, and I'll start probably on a very selfish level. So as a privileged professor in a well-funded institute with lots of talented students, it's fantastic to see young people arrive with incredible enthusiasm for doing projects, changing things in the field of construction. And I think what is it's a vehicle to teach better, to train people better for the real world, but it's also a vehicle to change things. And I think we have a societal problem on a much larger scale about sustainability. Sustainable construction has been with us for 20 years or more, and I think that many young people realize that something has to be done, but they're not convinced that we're on the right track, or they're convinced that something radically new is needed. And I think we're now in a stage where digital fabrication has had to take on seriously the questions of sustainability, of transfer to practice, of not just being a toy for academics. And I think this makes it, for us working on materials and in civil engineering and architecture, very exciting, because we ultimately want to do something for the real world. At the same time, we want to develop new visions and tools and etc. So I think we're at a kind of a crossroads where initial developments are now challenged to say, hey guys, this is nice, but go beyond niche applications. And I think this is something that I see motivating students. It's certainly something that our center has to do. So I hope that we can make a real large-scale impact in terms of reducing material consumption, and that this is driven by the level of enthusiasm that we see today in the field, in industry, but also with our students.
Well, I'm a layperson, of course. I'm not an engineer or an expert, but for somebody like me, one of the more exciting parts that I've been watching this morning in digital fabrication is the use of those robots on the construction site. And we heard this morning, though, that robots are not yet widely used on the construction site. And Mr. Yu, you talked a little bit about why that is, but maybe we can get a bit more detail about some of the stumbling blocks, why robots are not being used on the construction site, and what can be done to actually change that. So is it that we need to redesign the robots so that they can work better in the existing construction systems, or is it that we just need to rethink how our construction sites are set up to better accommodate robots that can do the work that maybe humans cannot? Do you want to tackle that, perhaps?
Sure. Great question. I mean, I guess it's both. So we might not need to redesign a robot. We first need to design the suitable robot for the construction site. And I wouldn't know if this is if this is a flying, if this is a walking robot, if it's on wheels. But we also need to change, I guess, the construction site. The question this morning or early afternoon was about is it then going to work on the construction site because there are so many different companies. And I think that is clearly an indicator it's not there yet. This is something we would need to change. Then also another thought, when we change this, it all needs to have a common plan somehow. And to make this robot work, and the hard part is the same as for maybe autonomous driving, is that you still, when you have these autonomous cars, you still have non-autonomous cars on the road. And I guess it would work perfectly with these autonomous cars if they would want to be autonomous cars. It's the same for the construction site. We're not able to build a house completely with robots, which would probably be easier because then you would not have any people on the construction site, but that's not possible, right? So we need to learn how we deal with this shared space problem, that we have robots and human or just construction workers in the same space, and that they help each other. And this human-machine interface is a huge topic in research.
So Dr. Liebert, I see you nodding your head. So would you like to add something to that?
Yeah, I agree completely. I think there are two topics. The automation and digitization in construction, I think that's an issue you have to take care of. Compared, or I would like to make an example from the aerospace industries. If you get onto YouTube and if you watch a video showing you how to assemble a Boeing Dreamliner 777, you will see that it's a complete empty building and all the fixtures, all the parts are brought in by robots, put together, assembled, and an assembled aircraft is leaving the building again and the building is afterwards empty. That's the highest flexibility you can get in automation. There is another topic you could check, that's Arena 36 close to Stuttgart, funded from Bosch and from Daimler, trying to do more or less the same in automotive. This means the message is the development of automation and robotics is following four revolutions. The first one, you know, that's using the standard robot behind the cage, producing cars, spot welding, whatever it is. Some type of the robots we are using out there. The second revolution is now to get them closer to humans, and that's driven from the approach at the end of the day getting to elderly care system, to get to cobot system supporting you 24 hours a day, which means that's a topic which is addressed now on a couple of applications it's already solved. Third one is to make them mobile. We still wrestle with different regulations between robots and HEVs, which means if you put a robot on an HEV, naming it a mobile robot, it's not allowed that the robot is moving while the HEV is moving, because it's under the restrictions per law, it's forbidden. If the robot is moving, you have to have a standstill. That's something we have to work on. And the next step then is to get the cognition into the robots, which means to make them easy to use and to make them more intelligent. I don't want to talk and stress too much the artificial intelligence, but let's get to big data and machine learning. I think all these topics you will find in the construction area if you concentrate on the digitization and trying to standardize a little bit processes, not the result, not the solution. If you get, for example, the automotive, 20 years ago you had the, for example, B3 series from BMW had 6 different types. Today you have close to 1,200 types, which means the production side gets more and more flexible. You can do different things, but on the other hand, what we, for example, learned is getting into the simulation tool working a little bit on second life, I would like to name it second production, really to produce your system virtually. And I think in the architecture you are quite far that's available on this side, much better than automation or automotive is doing. But then I think if you produce parts, if you develop parts, you have to do this end-to-end connection, which means to forward your knowledge from the development to the guys who have to do the design work, to put it into these digital simulation systems to give them a chance to play around virtually, and then download it into the applications. This means, getting it in a nutshell, I think the digitalization, that's a topic which can help robotics, and robotics on the other hand has to develop lightweight robots, human-machine interaction, making them mobile, and getting them available in the unstructured environment out there in your building sites.
All right, so we have the perspective from a corporation, and maybe now we can get, once again, turn to our researcher for your take on this. So, we keep saying the challenge is that interface, the human-robot interface, adapting to these unpredictable conditions on a construction site, and that's sort of, the task at hand. What needs to happen to improve that interface? And again, I'll pose the question more specifically: do the construction sites need to be revamped, or do we need to have a rethinking about how construction sites are organized to accommodate robots, or do the robots have to do the main accommodation?
So I think there is a long path for in situ robotics on construction sites. By the way, it reminds me that we have some extra copies of a special issue of Cement and Concrete Research, where a former colleague has written a very interesting paper on the research challenges on the subject. I could give you some copies here to hand out tomorrow to people interested. I think that is a very useful paper on the subject. Maybe a bit provocatively, I would say that researchers should learn more about what a construction site really is about, and that includes me. And vice versa. Construction site managers, workers, industry involved directly on the realization should learn more about what possibilities are. And I think that today there's not really many existing ready-to-use, cost-effective technologies for that. So and I'm a bit uncomfortable in saying we have to redesign the construction sites and planning, because the technologies that we're about to hopefully develop are so great that you guys have to change everything, right? So I think there's a long step, and in front of that, the big question to me is kind of divide and conquer. Identify where the opportunities are, see what tasks you can start making effectively on-site with a robot, with maybe some partial separation of the machines and the human, with some degree of complementarity, but the big picture of doing everything automatically in every case I think is just currently an illusion. We have to take it as a long-term kind of beacon, but pragmatically I think there's a lot of opportunities, and that's where the dialogue between research and industry is important, but it's including and going until the real job site. I think when we go out and start doing some applications, we regularly realize that we should have thought a couple steps further.
All right, so what I'm hearing is a call for perhaps more collaboration, more sharing of ideas and information to push the development of these technologies that are intended to be useful for all sorts of industries.
Sorry, I think really the question of identifying opportunities is essential. We've had that time and again. I mean, at the NCCR, we have companies coming every week who are interested in digitalization have that on their agenda. And typically, the ones where we start to identify opportunities is ones that come back. We have a couple of discussions. There's a cycle where they collect information, give some thought, come back, rediscuss. I think this exchange process and learning to know how the different parties are thinking really is how, I would say, the low-hanging fruits can be identified. And we can't do that alone, and I think that industry alone can't do that.
Would you like to add something to that from the perspective of APIS Core? Just wait.
Okay.
When it stops blinking and it's just green. There you go. Yep. Can we use yours? Okay, we'll do musical microphones.
Okay.
Actually, I can something add about our experience in real construction site. Because our target is printing on site, because within our company precast technology already done, and if you do it like a precast, you get back all logistics and something like this. And first, what we see on construction site, what you see in drawings and what you see in real life, it's two big difference. Well, okay, we have experience more in Asia and something like this. Maybe in Europe it's more curiously, but I think it's sometimes happened here too. And we see two ways. We can do preparation work more accurately, or we can develop our robot. Now we try put some sensor for work very accurately with starter bars, with MIP service and something like this. After that we start print, and our contractor say, please stop, it's too fast, we need to install software. We need to install MIP service, we need to install insulation. It's mean we need technology, full technology, how it's be integrated together in one program, step by step. Maybe soccer it's okay if it's two people because it's very complicated and prepare code for this, but for mine it's just 5 seconds, you need to just put circle on with fresh layer and after that. And also on this, it's huge challenge. It's material. What can work in real construction without protection, with different humidity, wind, different temperature, sun. It's main question. And another question, it's machine for mixing, for pumping, for dosage. It's another part. And of course, it's we need re-engineer construction process. It must be more friendly for 3D technology, and of course, we need put more information in our system to be more friendly with construction.
All right. Before we move on, would anybody in our audience like to add something to that on this question? Yep. Gentleman right over here. Thank you. Job for me.
I have a question. Digitization and automation is a big topic, not only in Europe but worldwide. So, what is the position of Europe in terms of know-how in universities but also corporations in comparison with USA, China, Japan, Korea, other parts of the world? I would like to hear the opinion of both university and corporations.
Which of you would like to volunteer and answer first? So, Dr. Liebert will.
I think I can try to answer a little bit in the robotics statistics. If you take a look on the worldwide robotics, you will find 52 industrial robot manufacturers like Kuka, ABB, Fanuc, Mudderman, and so on. And you will find 675, I think it's the actual data, service robot companies counted having really a product, creating like numbers and being in the market for at least 5 years. And we will find these robots in construction, we will find them in healthcare, in agri-food, in all the areas. But the good part is, if I ask you, what do you believe, where do you find all these service robot companies? Where are they located? How many of them do we have in Europe, or where are they? Do you have an idea? Normally I get the answer, okay, we have the feeling that's all located on the west coast, and beside of this in China and Asia. The good part of the story is 30% of these companies are located in Europe. And from the startup side, the most impressive startup scene from the robotic side is in Germany, which is another amazing topic nobody believes. And we did the double check, and it's not done by Kuka, it's done by Fraunhofer IPA, Martin Hegele. He's doing the statistics. And was so surprised that it looks like we are doing not as bad as we are, as we feel, or as we talk about the situation.
Anybody else want to comment?
In terms of digital fabrication and construction, I would obviously say that we are leaders, but that echoes comments that we get from colleagues around the world. So there are also other important programs that we've heard of that are developing in Europe.
And I guess for robotics, Zurich really is a hotspot. There was once one guy calling Zurich the Silicon Valley for robotics. I don't remember again who it was. But I think this also shows a bit about the companies that are now located here. It shows, or we can see this from like Zurich. It's everything is so close together between companies and the university, and I think especially the ETH here is driving this. And yeah, I mean, this is a huge opportunity not only for Switzerland but also for Europe. I think. And this is the same statement as Zurich before. I think Europe is doing really well in this, but it's not a reason to stop.
I did see another question from somebody on this side of the room.
I have a question concerning, the step from traditional construction to the use of robots. Do you think that we can do this step in one shot, or do you believe that, like in automotive or on the other industry, we have to go, in the first step, which would be the prefab, and then going from the prefab to the, I would say, application on the job site? And the question then is, why don't we see progress in the prefab in construction, because it's existing since 20 years, and when you look at the numbers, we don't see really progress. The prefab construction is not taking over the traditional.
Who would like to tackle that one, perhaps?
I think, it's a very vague question. Broad, excuse me, not vague. I think the digitalization, robotization in timber is making good progress. Of course, that's not the mass market, and if you go to the most used material, concrete, then there is a lot of challenges already for ordinary concrete production, hydration kinetics, rheology, segregation, and when you go towards digital processes, you typically have to pump, you change the mixture composition, that changes the price, you go into an operation window which is more narrow, and it makes things more delicate. Now, I also wanted to kind of move the discussion away from purely thinking of digital fabrication as meaning using robots, there's a whole wide range of other approaches. I think you will hear tomorrow about the high-low volt from my colleague Philippe Bloch, a cable tension formwork. That is highly digital in the moment of preparing this cable formwork, but the application is then standard of the concrete. I think there's many intermediate steps where the role of the digitalization is not necessarily to get a robot to do all the tasks that we currently do. And I think there's a lot of opportunities.
Well, why don't we pick up precisely on this? So, our guests are people who are producers of construction materials of all sorts, so adhesive sealants, coatings, and cement and other things. Can you talk about how digital fabrication technologies could possibly then create new market needs for these types of things? So are we going to have different types of adhesives? Are we going to need different formulation concepts? And if yes, in which direction?
Well, I'll pick maybe on a specific case I was discussing a bit before the whole thing kicked off this afternoon. In terms of, I guess there's a lot of sealants based on acrylics that you are producing, selling, etc., which with respect to silicon sealants are more expensive. They have their performance advantages, and I think but this is probably speculative, but technologies that will allow you either robotically or by augmented reality, human capacity, to better dose the use of the compound, to maybe have a software that's really telling you where you have to put how much of the compound to get the best possible performance. I think that is something that, if indeed your challenge with those compounds is the higher price, the material usage optimization could be a very important aspect.
Okay, so efficiency is a possible benefit to digital fabrication. How else could things change then for people who are producing these types of construction materials? Do you want to add something to that?
No, it's hard for me more on the robotic side. I don't yet see into the world of all these coatings and sealants. But I guess really the control over these materials is key to bring them, or to use them on a mobile robot. The mobile robot needs to be able to control the state of the material. And I don't know if this is the case.
As a materials person, I will maybe
please
speak a bit more to this. I think for materials in general, for cementitious materials in particular, there's a big issue of robustness. The stuff is so cheap that they can afford them to supply it in variable quality. You get a new batch, it's not behaving as it did. And it can respond, that is in general with cementitious materials a challenge. Robotic processes will typically push the system to a more sensitive, higher demanding zone. That's a problem, a challenge, but it's also an opportunity for material suppliers. If you have the knowledge of providing materials that will behave more reliably within a narrower window of operation, of property evolution, that is a clearer added value that you can market. Of course, down the line, the application has to pay off for that extra price. But I think that is clearly an area where I see the potential.
Can I add something to that?
Yeah, I would like to come back to the question, the automation in one step compared with automotive. I think automotive is reinventing the automation in the moment, getting from body in white welding lines now to the final assembly. And the final assembly the question of the problem is they're running out of manpower. They don't have the people over there, and they need the assistance from the robots. And the learning was the old 80-20 rule. If you do 80% automation, you can do it on 20% of the costs. And for the 20%, you should use the humans. Because the humans, for sure, for the next 20, 30 years, are much better in vision than the vision systems, are much better in the sensitivity in grasping than the gripping systems. And this combination, this learning, took place now in aerospace. We know it from healthcare, and I believe that you should think about this on the construction side too. Not thinking about dark automation, getting into smart automation, combining people with robot-assistive systems. I think that's the breakthrough strategy.
Did you want to add something to that?
Yeah, about new opportunity on material. Our company use ceramics, not fresh mortar nor concrete, and I think here some ceramics producers, and I prefer focused mineral-based material, not only cementitious, because it's a lot of now opportunity on this direction. And for example, our vision, if we use mobile robot on construction site, we store dry mix in silo and use it part by part. And very nice what we control each parameters, and we exactly know what in our silo. And it's mean in low construction, dry mix producer can part market from bricks, get silicate block, different part of boards or something like this. It can open huge market, but not very expensive. It's must be a real normal product with normal price.
Does someone in our audience have something to add to that, or perhaps a question?
I think I got a smile from your last statement. Perfect.
I was just imagining 5 years from now there'll be these book series, something for dummies. There'll be smart robots for dummies. I was kind of going through the idea of smart robots for smart humans, but it kind of goes along this question of moving away from the robot does it all to dividing, but also I think augmented reality and the ability of bringing tools to a skilled worker so that he does also a better job. And I think there's lots of things, feedback, force sensors you can put on gloves, and all kinds of things that are currently not at all looked at, to my knowledge, that have a great potential and can probably be much better integrated into the complexity of a constantly changing job site. Incidentally, just also you noticed on the video of the mesh mold, the bars are being brought by the humans. They're feeding the robot, which is doing very precise, repetitive works, and that's worth developing. The whole back infrastructure is not really worth developing and automating. And then beyond that, I think helping skilled workers to do better tasks is something that has a lot of potential. I have a topic that I call Robococo, which is a vision of a renewal of a Rococo style. It's kind of gypsum decoration elements, but where either robots or feedback sensors would help to make such decorations, assuming you want them, much more cost effective than they have become today.
Professor Pat, you mentioned something that I think a lot of people, when they think about robots doing these jobs, and you explicitly said it doesn't mean that humans will no longer be needed, or this vision of that robots will replace all people and all take over everybody's job. The way that you seem to be describing it is that this cooperation is actually going to be more important moving forward between machines and robots. So maybe we can hear from our panel a little bit more detail about how exactly this type of interaction could work on a construction site, and how will these interactions change as digital fabrication plays a greater role, like the human element, the machine element, and the technology element, how all those will fit together. Perhaps the other researcher on the other side of our panel can start.
The current interface to a robot is a computer. It might be an iPad where you click on, it might be your laptop, you log in, you change parameters, you execute programs. That's how it looks. But that's not how it's going to be useful on a construction site. Especially, because you would need the training of the people to do this or to understand these complicated interfaces. This is not the way. The way it should be, in my opinion, is that the robot has somehow the capability to sense intentions of humans. For example, a robot I would, as a person, need to weld something really heavy onto something else, also really heavy. I would have these two robots carrying these two heavy things and then pushing it together. I would somehow then maybe see myself guiding these robots to put these two pieces together, and then I as a human fix this together. So there's no interface the way we know it now, which is a laptop or an iPad, but more that the robot somehow senses the intention of a worker. I think this would be the way to go. But it sounds terribly hard, and it is, I guess, terribly hard.
Is that the direction that industry is pushing for?
Yeah, we are working on this since many years. I think we started with the introduction of the PC-based controller many years ago, following the mainstream, and looking today, the IT technology is getting in close contact with the mechatronics, which means you have all these systems, from the intelligent band now, which can give you error messages from the robot, face recognition if you approach a system, and the system can detect if you are trained or not, and shut down or not shut down depending on the behavior of a person. That's all available. The big challenge we have in the moment is to make this safe, really to have safe vision, recognizing that's a human being, and the human being is really there and not in a different place, which means trusting the pictures you can see, because recognizing people, from the airport, from the safety system, that's done, but really talking about safe technology, that's a different story. And my strong belief that in a couple of years you even don't need training to work with robots. It's like getting a drilling machine or a notebook or a screwdriver. You get a robot and the robot is supporting it. That's for sure coming, and there is the discussion we have with the artificial intelligence is for sure playing a role in there, where we have to be very careful with physical AI, because it's different if the AI is only on soft parts or if it's a mechanical system. It's following their own thinking, what perhaps the human expects being in front of the robot, but that's a strong development in the whole community, and it's discussed very much in the topic groups about construction robotics. And I think, as I mentioned before, the big challenge is really trying. I like the example with the divide and conquer. Really to try to put, I know it's unstructured, it's individual, it's new materials, and the behavior of the materials is depending on whatever it is, but I believe it's possible to get at least a little bit a standardized approach into this automation. This will help a lot.
We only have a few more minutes left, and precisely because, as Professor Flatt said to us, digital fabrication is not just about robots. It's about much more. And I do want to ask one last question, kind of a much more technical one. If you could maybe talk to us about how digital fabrication trends are going to influence raw material requirements. You talked about the cement that you use is mineral-based, and for the customers, the people here who produce construction materials, what does that mean for their business and how they make these construction materials? So, who would like to tackle that one? I think there's only one man who seems to know that.
Basically, yeah, it means, for many cases, it means you have to learn to handle variations in composition that are relatively natural and expected for the level of price of materials that go into construction. And the lower the price, the more those variations tend to be. So, so then if you go to something with less variations, you have a higher cost, and at the end of the day, your application has to be worth it. So I think, I spent some time in industry. I know that at least at some point in time in the tunneling business, there was a lot of emphasis on doing the concrete spraying because that was the most difficult part. So companies would consider that's the thing. If you can do that, then you get into the tunneling contract and you sell all your other stuff, right? So I think there are cases where companies have invested in knowing how to handle the variability of material performance in different conditions, and also business models where if you can do the difficult part, then you come along with all kinds of other stuff back. So I think it might be something to bring into the consideration. Even if nowadays there's more and more like compartmentalization with purchasing everything individually, maybe it's no more such a good business case. But I think, identifying the areas where you can control the properties, you can do the difficult stuff, and then you can bring in other things. That could be something to think about.
Any final questions or comments from our audience? Specifically on this, perhaps?
I have a different one left.
Pardon?
I have a different one left.
Different one, sorry?
A different question.
Sure, by all means.
Coming back to the technology leadership in robotics, and of course I'm looking at you, Bernd Lietert. It's surprising to learn it's 30 companies or 50 and 30 of them in Germany, including startups. So Germany still has a good position in there. But looking at your company, for example, from my perception as a layman in this area, you are the shining star in that, and you belong now to a Chinese company. How does this feel? And what does it mean for overall leadership? It feels like China is buying the mid-sized companies in Germany, or one after the other, or is this not true? What's the inside view of that?
Getting political here.
Yeah, that's exactly the question I really don't need. No, what happened? We have a Chinese owner. That's true. He owns 94% of our shares. Does it make a difference for Cook in the moment? In the moment, no, because we are still a German company listed in the Frankfurt Stock Exchange, which means it's independent who really owns the shares, and I think many others even don't know who is the owner of the shares. Getting a little bit into the view of China, the interesting part is everybody expected that we will end up in a replacement of the management, which didn't happen, which is 100% guaranteed if an American company would overtake you. The first who has to go is the CEO, the second one the CFO. We even don't have a Chinese manager. We only have the Chinese people sitting in the supervisory board. And supervisory board is quite different on the German law than the board you know from Switzerland, for example, or from US, which means they only have right to check and to consult. They don't have a right to advise. It's a clear order between these. That's a good part. The bad part is that we have to rethink about our plannings. I was invited in a couple of management meetings we had with our owner, and the Chinese view over the next 5 or 10 years is quite different than ours. From planning, from speed of development, I think that's something we really have to learn. The biggest threat, and that's something I had to discuss many times with the European Commission, was or is, I think it's not the discussion if IP goes to China, because we are a global player and we are delivering our robot to the world market, which means we have our best robot, the LBR EVA, that's the first one who has the medical FDA approval, is delivered to China, to Chinese hospitals. We are delivering our automotive robots into the assembly plants from Daimler and VW and so on, which are located in China. The technology is there. The biggest problem would be if they would tell us, okay, stop delivering your stuff to Europe. That would be for us a disaster, because then we really would have a problem in Europe if this starts. And I know a good friend of mine, he was running a company, augmented reality company called Dr. Altet was Metaio, located in Munich. Augmented reality. They did a lot of development for VW, and in the middle of the discussion about Google Glasses and the HoloLens, the company was bought from Apple and taken from the market, which means it's not that the US took the stuff, but they are not allowed to deliver it any longer in Europe, and we had to find different solutions. I think that's a big problem. The last statement, if you talk to them and they make us believe that they are not interested in making KUKA a Chinese company because they spent close to 5 billion euro for the deal, they would have a cheaper chance to start up a Chinese robot manufacturer. They are much more interested in owning this brand being located in Germany. They told us years before, in the last decade, they bought ground or hotels or whatever it is, and now they try to invest in technology. And if you double check this, if you look, for example, to the Harbin University, they have a robot lab which is on the same size like the Fraunhofer IPA in Stuttgart or the DLR in Oberpfaffenhofen, which means we are teaching their professors, and they have much more students than we can imagine being interested in learning in robotics. Therefore, it's challenging, but let's say it's an open battle to stay in Europe and to make Europe stronger and stronger, and that's the main reason why we are so interested in pushing, especially from KUKA side, to push on the EU robotics organization to make robotics better and better in Europe, and doing a little bit of marketing for the organization. We have 30 topic groups dealing with different technologies, and one really good topic group is robots in construction. And I think if you are interested, you could double check the homepage, getting into this field and talk to these people. It's run by Sigrid, perhaps you know her, Sigrid Brekopchan from Aachen.
I apologize for this question.
I'm afraid we're going to have to leave it there, though. Dr. Liepert. Many thanks indeed to you, Dominic Hewett. Thank you, Sergei Nefedov. Thank you to you and Professor Flatt also for all of your detailed answers. We really appreciate having all of you gentlemen on our panel. Let's give them a warm round of applause. Thank you.